Hello. Um, I want to make another video, not focusing on layout sketches, but actually how to organize your Onshape ecosystem because this is very, very important as we learned from the many resource limit exceeded errors that we got last year. So hopefully next year, everything should go a lot faster and everything should load a lot quicker and that type of stuff. And I haven't made a script for this one, so I'm gonna just try to YOLO it and use this slideshow that I actually so this slideshow is from the conference that I attended in Houston. So I'm just gonna be following it and then using last year as an example. So Onshape best practices for FRC. We're gonna skip this and we're gonna skip that. Okay, set of strategies. So what we did last season was, if my browser works, is we had one document for each separate subsystem. So we had one for the drive base, one for the funnel, one for the elevator, that type of stuff. Um, this is good. This is already a lot better from past years that we had, but one thing that we did wrong was we made the layout sketch and the master doc two separate things. What we actually had to do was make the layout sketch and the master doc the same thing. So yes, I know it sounds weird, but that's what the guy at the conference recommended. So you would literally derive the sketches from here onto the other documents that have your other subsystems, and then you would import them all back into an assembly here for the master doc, or like for the master assembly of your bot. Um, and that should make stuff a lot more organized here, since it's going to be in the same exact doc. Um, Another thing that I didn't like and that I'm kind of looking back onto now, what we did is, if you guys remember, we every single time that we made a change to the elevator and we wanted to update it to the master doc, we would have to go, since the elevator was imported into the, I'm pretty sure it was into the Tootsie Slide doc, we would have to update the Tootsie Slide doc and make a new version, and then we would have to go into the master doc and update it there. So just a lot of different threads that I didn't really like, and that actually did slow us down a lot. So what we should have done is we should have created the elevator, like not connect any of these docs together. So we shouldn't have imported the elevator into the Tootsie Slide doc. We should have just made the Tootsie Slide by itself and then connect everything in the master doc, because then that would have saved a lot of time. Um, we might have to, again, that's just what my gut feeling is telling me. We might have to interconnect some docs together, but like last year was just a huge pain, especially with the elevator, because we were just making so many changes to it and we had to update the master doc. All right, let's go back onto the slideshow. All right. Um, so they over here, as you see, this is team 6329. They have like a naming uh standard for their documents. I mean, I was fine with last year's. Um, this is fine with me. I don't know what this is actually, but we're gonna have to. Nah, we'll figure it. Like, I'm fine with this. This looks great. If you don't like it, we can talk. We can set up a standard for our team. Um, let's see. So yada yada. Okay, so I already talked about this in the layout sketch video, but top-down design. Um, this is a great example of top-down design. If you remember in my layout sketch video, I told you that top-down design is kind of like if you went into isometric view, like we see here, you are able to see the robot in 3D. And it's just so cool, man. Like, holy, it's so clean and so nice. Because then it makes 3D finding stuff so much easier. Like you're just gonna have to select, like for example, this box to press extrude. It just makes life so much easier. Um, so over here, it, you know, does this brief overview of what it is, right? I told you guys that you will have to use a lot, you will have to use the plane feature, create a lot of new planes. And like you can see here, that is definitely true. like what you have a plane here, you have a plane in the middle, you have a plane over there on the other side, you have a top-down plane, middle plane. Again, a lot of plane features. Um, but in the end, it makes stuff very, very clean. All right. Um, so we have already been using this last year. We have been using Derive. As I told you guys how we like interconnected document, or well, we derived layout sketches from the layout sketch doc into the mechanism docs. And it worked really nicely, I would say. Um, this is why when you go back here, they tell us to draw the sketches as they actually are in real life. Because if you don't and you derive the layout sketch into the subsystem document, um, then once you start assembling the subsystem into the actual bot, it's going to be messed up. Um, so basically, you want to layout sketch the parts of the robot as they are in real life, and you actually want to start kind of assembling in the part studio. Like if you guys don't remember, if we can go into the Tosi slide doc and we go into the part studio, if it loads, see this is what we do not want next year. This is going to be such a pain, especially if we want to do a complicated robot. Um, there you go. So probably has to load. Oh wait, no, it doesn't have to load it. I just have to use the rollback bar. This is another great tool. Use the rollback bar. It's very useful to go back and um, look at like the changes you made to your bot. It's also very useful because, for example, if you made a folder and you want to add new features to the folder, what you can do is you can just slide this rollback bar kind of into the folder, as you can see there. It kind of slots into right underneath each side fillet. And then if you, for example, create a new sketch, the new sketch is going to be made inside of that folder underneath each side fillet. Let's just, for example, like see how long this is taking to generate. So 1.23 seconds. Never mind. 14, 14 seconds. Um, and then if we go all the way back down, yeah. So that is a huge problem. If you guys don't know what I just did, I just pressed on this and it's going to show you the generation times. So as you can see here, the top things that are taking the most time to load are feature scripts. Um, yes, it's true. Feature scripts take a lot of time to load. You generally want to have a region time of less than 10 seconds. I think we have reached 58 seconds this past season. Um, so we do have to work on that. But again, hopefully this video should declutter some of this because this is such a pain. And I think this is like our least time intensive document that we made past season. So yeah, pain. But anyway, as you can see here, we've already kind of been uh assembling in the part studio. Like this plate is exactly where it's going to be in the assembly. This plate is also exactly where it's going to be in the assembly. Okay, well these pulleys are an exception. We kind of just hide them. This whole assembly over here is exactly how it's going to be in the assembly. You get what I mean, right? You want your layout sketches. You want to start assembling in the part studio from your layout sketches, and then in your part studios as well. All right. Um, let's see. Top-down design, we already did that. Okay. We can just take a look at their Onshape document and you'll see just how clean. Like look, it loads so fast. It's so clean, right? So you see that their master assembly tab is here, and this is actually their layout sketch document as well, right? So here it's oh my God, it's so nice, right? This is a beautiful example of top-down assembly, right? You can see a 3D representation of the bot already. You can see how many planes they've made. Um, plane six, le- left superstructure, right? Again, you're gonna have to use a lot of planes. And as you see, their layout sketches aren't that. um, kind of aren't that sophisticated as well. One thing I forgot to mention in yesterday's video is when to start to make the gears, like when to start to make the gear meshes. You want to start that after you finalize the positions of your pivots, the positions of your outtakes, that type of stuff. Wait, you don't start to make your gear meshes right after you've made your pivots or your outtake wheels because they are very prone to change. And so then you're going to have to use recalc again to find another correct center to center distance. And it's just going to be a lot of waste of time. So please be patient on making gear mechs until you finalize your outtake or your pivot or anywhere else you plan to use gears or pulleys. So yeah, this is beautiful, just beautiful. Um, I'm gonna send the slideshow in the Discord chat, but it's just beautiful. It's so good. So, let's just make sure that I'm actually recording the correct thing. So that's good. It would be really funny if I was recording my other screen. Anyway, moving on. And there's also other robots that you can check out. And also top down, do this. This is beautiful. Onshape has a great course, and FRC design is a new thing. I think it was introduced like a year ago, and it's so good. So check it out. All right, so part studio performance, already talked about this a little bit. Um, let's see, yada yada yada. Yes, so organization is very, very important. Um, I think the Tazi slide document was our most organized document that we've ever made in the history of our team. Um, but it's still not the best. It's not the best that it can be. Um, here they have a couple of examples. So this is a beautiful example of how to organize your document. See, you have a use of a lot of folders. You have really good naming schemes. You don't have like, oh yeah, mirror. Okay, well, mirror one. I disapprove of this already. You don't have like sketch one, sketch two, sketch 538,000, right? And then if you look at this one, this is like, it's all right because you see fillet one, extra two, sketch two. Also, you don't see a lot of folders. And then this is just, I'm gonna slap you if you do this. No errors. Please do not have any errors. This is bad. Um, all right. So here they have a couple of general guidelines for how to keep your on-sheet document organized. Try to keep features less than 250. Try to keep parts less than 20. And then, as I said before, regeneration time less than 10 seconds, right? Pretty straightforward. I already showed you guys how to do this. Show generation times. We already saw that we were at 15 seconds. Um, Horrible, but I mean 5 seconds off. Still horrible though. And this is where it gets interesting. So in the conference, they mentioned primary parts, secondary parts, and tertiary parts. So primary parts are kind of like the main parts of your bots. They're kind of like the side plates, they're the box tubes, they're the rollers, they're the never mind. No, box tubes are not. They're secondary parts. So they're just critical parts of the mechanism, right, that actually hold your subsystem together. So the plates, plate over here, plate over there, plate here, some gussets. Secondary parts, oh, that was my iPad falling to the ground, but it was okay. Secondary parts rely on the primary parts to set their geometry, and I totally did not read that off the slide, trust. So gussets, tubes, pulleys, gears. I lied about pulleys and gears. I'm so good at this. Um, let's see, with the rollers as well, they rely on the geometry, um, that type of stuff. They're like, yeah, secondary parts. Tertiary parts are like components that do not really rely on any geometry, that they kind of just follow their own gist. So like pulleys, for example, they do not rely on the dimension from here to here, right? They don't. Because all you need is just the correct center distance, and you also just need the correct number of teeth. Same with gears. Camera mounts, yes, they do rely on the geometry, but that's just for like the distance, right? From here to here, from here to here. Um, right? It's tertiary parts, right? Um, so what you can do is to follow these guidelines. If you see that you have a lot of like tertiary parts, what you can do is you can actually make a separate part studio, and then if, for example, you need a certain box tube from the main part studio to make the gear, you can derive that box tube into this part studio and then make the gear inside of this part studio, and then uh, place that gear inside of the assembly. Same with like camera mounts. If you need like two certain box tubes or two certain plates to make the camera mount, and that's it, like you don't need anything else, derive there's those two plates or those two box tubes into this part studio, and then make a camera mount here, and then put it into the assembly. That's gonna reduce a lot of time, save a lot of time. All right, as you see here, right? So assembly performance. This is very, very important as well. So I was talking earlier about how you want to already start assembling instead of the part studio. This is very, very important because then you don't have to use a lot of mates inside of the assembly. We used too many mates inside of our assembly. Um, yeah, we don't want this. So what assembling inside of the part studio helps with is you can just import this whole part studio here, and then just use the group feature to group everything here together, and then just not use any mates at all. Um, what you can also do is, for example, if you want to, I don't know, if you want to add this like assembly into the assembly of the Dale, what you can do is you can mate it first, right? Just uh I forgot how Onshape works, guys. This is no bueno. Made it first to the correct spot, right? And then what you can do is you can delete that mate and then use the group feature to group everything together, right? I know it's tedious, but it will save a lot of time. Use mates where you do need to use mates. So for example, if you we had to make this thing rotate, right? So we had to use a revolute mate there. That's tankable. Don't worry about it. We'll fix that later. Um, and usually, so what you would have is this whole assembly here would be grouped together, right? And then you would use a trick I just told you to add new components of that assembly into the group. Oh yeah. Another really nice feature in Onshape is you can actually reduce the amount of polygons or like the amount of triangles that are used to model your parts. So if you go into the part studio and you select, for example, this box over here, you can right click it and go into edit appearance. And then over here, you're going to see tessellation quality. It's already on coarse, which is the lowest it can be. And that should hopefully save you some time and loading. So very useful. Um, 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 um. And yep, overall document performance. Um, yeah. And then if you do want to have a document with field, uh, make that a separate document to just import the raw into there. That's what we did this last year. We already know MKCAD, Crayon CAD. That's actually very useful for brainstorming. So how you use it is you go into an assembly, and then you go into insert, and then other documents, and then what you search up is Crayon CAD. And then you have to get like the original one, which should have like a green icon, Crayon CAD. You press on it, go into assemblies, and here you see a lot of basic FRC mechanisms that you can combine to make like a visual representation of what you're thinking about. I highly recommend to play around with this. We used it last year, actually. It didn't come like it wasn't very useful, but I really want to actually, and I think it wasn't very useful because we just didn't know how to use it very effectively, but I really want to try to use it next season. So play around with that. Um, Feature scripts, where you know this. So yeah, I know that was kind of quick, but I just want to tell you guys like a brief intro, a brief overview of how to manage your Onshape ecosystem. So hopefully we get down to those 10 seconds next season and less than two resource limit, you know what? No, zero resource limit exceeded errors. Yeah.